In Java, you can represent numbers as either primitive values or as complex objects. I'm going to start by showing you how you represent them as primitives, and then show how to convert them into complex objects when needed. A primitive data type is a simple value. It represents only a single value and not many. That's one of the big differences between primitive values and complex objects. A primitive always points to a single value. Primitive data types are stored in the fastest available memory, whereas complex objects are stored in heap memory. When you're running an application, you won't see significant differences, but they do exist. Primitives can be used to represent numeric, logical, or single character values. They can't be used to represent strings, dates, or other things that have to be represented as complex objects. Most of your numeric values will be declared as primitives. You'll only need to use complex objects where you need to do conversions, or you need to guarantee precision when doing certain kinds of calculations. When you declare a primitive data type, you spell the data type in all lowercase. So for example, int, or byte would be spelled all lowercase. There are also classes with these names, but they'll have an uppercase initial character. Here are the numeric primitive data types. The byte data type takes 8 bits and can represent numbers starting at -128 and going to a maximum of 127. The short integer takes 16 bits and has much greater range. And the most commonly used integer data type, int, takes 32 bits of memory and has a minimum and maximum of over 2 million in each direction. There is also a long integer. It takes twice the memory that an int does and should only be used when you're representing very large numbers. Then there are two primitives that can represent floating values. The float takes 32 bits, and the double takes 64 bits. You'll see developers represent currency values frequently with doubles, but as I'll explain later, typically you'll want to use a special class called Big Decimal for that sort of purpose. When you use primitives, you can set their values directly using literal representations of numbers. For the first three primitive data types, byte, short, and int, the syntax of the number is pretty conventional. It's just a numeric value without any quotes. You can't include string values such as currency symbols or commas. When you get into the larger numbers, the long, the float, and the double, the syntax is a little different. For long values, a literal numeric should be followed with the letter L for long. You can use either an upper or lowercase l, but because the lowercase usually looks a lot like a 1, typically developers will use the uppercase L. The float value takes a lowercase f, and the double value a lowercase d. Again, you could use uppercase, but most developers use lowercase for these. If you don't put in those additional alphabetical characters, usually things will still work out okay, but what's happening internally may surprise you. If you don't put in that additional alphabetical character into your code, the value will be cast based on a set of rules that Java follows. For example, the 100 would initially be cast as a byte, and then it would be upcast to the long. So you're actually taking more memory than necessary, creating two values where only one is needed. So it's recommended that if you're explicitly using a literal to represent a long, a float, or a double, that you use these characters. In addition to the primitive data types for numbers, there are also a set of helper classes that are a part of the Java class library. Each of these helper classes includes tools for converting and outputting numeric values. Here's a listing of the data types on the left, and their matching helper classes on the right. For the most part, the names match. Byte is byte, short is short, and so on, and the only difference is the initial character. The primitive data type is all lowercase. The class name has an initial uppercase character. The only difference is in the integer, where the primitive data type is int, and the name of the helper class is integer with an uppercase I. The helper classes have all sorts of great tools in them, and they're always available to your Java code. Here's an example. The double class provides methods and other tools for converting and managing double values. Let's say you started off with a literal double value of 156.5d, and you assigned that to a primitive variable of double value. Well, in order to convert it, the first step would be to create an instance of the double class. This would be the syntax. The data type has double with an uppercase D, which means the helper class and not the primitive. I'm constructing an instance of the double class and passing in the primitive value. Now I can convert that value using a set of methods called byteValue, int value, float value, and to string. These are instance methods or class methods of the double class. We'll learn more about what that means in later videos, but for now, just take it to mean that you can call these methods whenever you create an instance of the class. Because a double value can have more precision than, say, a byte or an int, calling the syntax will result in truncating the value. So the result of my int value would be simply 156. The result of my byte value, though, because 156 exceeds the available range of a byte, would wrap around, and you would actually end up with a negative number. I'll show you examples of these in some of the code samples. When you declare a number using a primitive data type, if you don't set the value initially, it defaults to 0. So for example, here I'm declaring a variable called myInt, and I'm setting it using the int data type. I'm not including the equals assignment operator or an initial value. And so the result is that myInt is initially assigned as 0. You'll see that this is true of all the primitive numerics. Now when you get into complex objects, instances of classes, the rules are different, but we'll talk about that later. There's one other major issue to know about when you're working with numbers. If your application requires numeric precision when you're doing calculations or rounding, you shouldn't use primitives for this purpose. The problem is that primitive values are stored in memory in a way that can't guarantee that precision. Instead, you should use a class called Big Decimal. Especially when you're working with currency values and you need to do certain kinds of math, the Big Decimal class can help you guarantee that precision. Here's an example of what can go wrong. Let's say that you're starting off with a primitive value, in this case a literal, of 1115.37. I'm going to create an instance of the Big Decimal class called Payment, and I'm constructing it directly from that literal value. And then I'm going to output that value as a string. You might think you'd see the value 1115.37 as a string, but in fact, you're going to see something like this. The exact value is going to vary depending on your system, your processor, and other variables. But internally, the number is stored in a very surprising way. So when you're working with currency values, it's strongly recommended that you construct your big decimals based on strings. This guarantees that you're talking about exactly the value you think you're talking about. Let's say, for example, that you start off with a double value, once again, of 1115.37. Before you create your instance of Big Decimal, you should first get a string representation of the number. This guarantees that any additional decimal values are truncated, and you're only working with the value you want. So the second line of code uses the double classes toString method and converts to a value called DS, data typed as a string. Now I construct the instance of Big Decimal based on the string, and then output the value, and now I get what I expect. We'll talk more about the Big Decimal class in a later video in the series. So that's a look at representing numeric values in Java. For most purposes, the primitive data types do a great job, but in many cases, you'll want to use the numeric helper classes that are a part of the class library, and specifically when you're working with currency values and doing calculations and rounding, you should look at the Big Decimal class.